Hello student, this is my fourth video in which I am going to explain the concept of electric field. As we already learned, electric field is represented by E and its relation is kq upon r square. Now let us consider a charge q1 and B lies at distance r. So electric field at B is kq1 upon r square. I am representing it by E1. Similarly, let us say I have a charge q2 and A lies at distance r. So electric field due to q2 at distance r is equal to kq2 upon r square. So it means that this A point is having an electric field due to q2 and B point having an electric field due to q1. So therefore I can say q1 is lying in the electric field region of charge q2. So at A, the electric field is due to q2. Similarly, at B, electric field is due to q1. So therefore, charge q1 lies in the electric field region of q2 and charge q2 lies in the electric field region of q1. So what does it mean? It means that both these charges are lying in the electric field region of each other. So it means that this charge q1 is in the region of electric field E2 and this charge q2 is in the region of electric field E1. So what does it mean? It means that they are exerting force on each other because they are lying in the electric field region of each other. So how can you think of force? Force on q1 charge, which is in the region of electric field E2, is given by QE. Q is the charge and E2 is the electric field in which Q1 charge lies. And we know that E2 relation is KQ2 upon R square. So we have expressed that part and we got the same result which we learned in Coulomb's law. Similarly, Q2 charge is lying in the electric field region of Q1. So it means that what will be the force on Q2? That is given by Q2 E1, where Q2 is the charge at this position and at this position there is an electric field due to Q1. So we will write in this manner and E1 comes out to be KQ1 upon R square. So it means that force again comes out to be KQ1 Q2 by R square. So this satisfies the concept of Coulomb's law. So it means that if any charge is lying in the electric field region E, so what will be the force experienced by it? That comes out to be F equals to QE. So in this manner, we have the concept of electric field. And in between the two charges, if at any point the net electric field is 0, then that point is called neutral point. So just I am again reminding you, the neutral point is that point where net electric field is 0. Let us say I have a charge Q. Both charges are of equal nature and equal magnitude. So at point M, I want to find out the electric field. Let us say M is a midpoint and it is at distance R and same distance from Q. So what is the electric field due to this charge at distance R? kq upon r square. Similarly, due to this charge, kq upon r square. And we know that the charge is positive charge have an electric field directed away. So this is the charge q represented by 1 and the electric field due to is E1, and since this is a test charge and test charge is always positive in nature, so this positive charge is going to repel. So this positive charge going to repel the test charge away, so electric field is in this direction. Similar, this is also positive charge and the test charge is already positive in nature, so this charge is going to repel, therefore the electric field is in this direction. So it means that E1 and E2 both are kq by r square and they are opposite to each other. That's why at this point I can say the net electric field is 0 because they cancel each other. So at midpoint electric field is 0. If I have the point very closer to Q, and since it is at this point, the test charge considered here, so electric field is directed away, and this charge is going to repel in this direction, but the influence of this charge is more here, so net electric field is in this direction. If I take the point closer to this Q, the effect of this charge Q will be more, therefore the net electric field is in this direction. So it means that if you have a point very closer to the charge, the influence of that charge will be more. Now let us consider the other case here outside. At this point again I am taking a test charge, and since test charge is always positive, so this charge is going to repel, and similarly this charge going to repel. The net electric field is in this direction. Similarly the net electric field is in this direction. So I am just plotting the graph here. At midpoint electric field